We've spent all this time talking about parallelograms and all of the subgroups of parallelograms. Now we're going to talk about two other types of quadrilaterals, and these are trapezoids and kites. What is a trapezoid, you ask? Excellent question. Let me tell you. A trapezoid is a quadrilateral with exactly one pair of parallel sides. This word exactly is extremely important. We call these parallel sides of a trapezoid the bases. So every trapezoid has exactly two bases. The two sides that are not parallel we call legs. Do you get the idea that there are a lot of different meanings to legs? And finally, we call the pairs of angles that are attached to either base the base angles. So every trapezoid has two pairs of base angles. And just like with triangles, we also have isosceles trapezoids. Isosceles trapezoids are trapezoids in which the two legs are congruent. Which brings us to our first theorem, the Isosceles Trapezoid Theorem. If a quadrilateral is an isosceles trapezoid, and you will notice that we have a pair of parallel sides, and the legs are congruent, then each pair of base angles is congruent. So you'll notice that angle U and angle Q are one pair of base angles, so they are congruent. And angle A and angle D are another pair of base angles, so they are congruent. This is very similar to the isosceles triangle theorem that says the base angles are congruent, but in an isosceles trapezoid there are two pairs of base angles, and within the pairs the angles are congruent to each other. Now that we know a little bit about trapezoids, particularly isosceles trapezoids, let's put all of our information to work. Here we have the isosceles trapezoid TRAP. And because we know that the non-parallel sides are legs, and in an isosceles trapezoid, the legs are congruent. But what's even more important is we just learned the isosceles trapezoid theorem, which means that each pair of base angles are congruent. So angle A and angle P must be congruent. We know that the measure of angle P is going to be 57 degrees. Well, that's wonderful, you say. How is that going to help us? Well, there are two possible ways to do this problem. I prefer the more direct route. Because we know that the two bases of a trapezoid are parallel, we have two parallel lines cut by a transversal. What do we know about same-side interior angles of parallel lines? Hopefully, you remember from Chapter 3 that same-side interior angles of parallel lines are supplementary. So that means that angle P and angle T are supplementary. Well, if angle P and angle T are supplementary, that means the measure of angle P plus the measure of angle T has to be 180 degrees. Substituting in the value that we just discovered for angle P, we now have the equation 57 degrees plus the measure of angle T is equal to 180 degrees. And then if I subtract 57 degrees from both sides, we find out that the measure of angle T is 123 degrees. That's really quite easy if you remember our theorems about parallel lines and transversals. Now let's look at a more practical application. The model of the bridge to the right is built from isosceles triangles. So we can see these isosceles triangles here. The vertex angle of triangle ZOD is 38 degrees. How does that help us, you ask? Well, since it's an isosceles triangle, we know that side ZO and side DO are congruent. So the angles opposite those will also be congruent. So these two angles down here have to have the same measure. So what is x? Well, we did quite a bit of these with our last chapter. The three angles added together have to equal 180 degrees. So I'm going to combine the like terms and subtract 38 from both sides of the equation at the same time. So we now know that those base angles are 71 degrees. Notice that we're looking for the measures of the base angles of the trapezoid, and one of the base measures is z, and we just found that to be 71 degrees. Also, let's keep in mind that all three of these triangles are isosceles. So segment OD has to be congruent to segment RD. And likewise, segment DR has to be congruent to segment VR. So all four of these segments, as we zigzag across the trapezoid here, are congruent, which makes trapezoid ORVZ an isosceles trapezoid. And since we just found x, which happens to be the measure of angle z, we also found the measure of angle v here, because in an isosceles trapezoid, the base angle pairs are congruent. So the measure of angle v is also 71 degrees. How do we find the other base angle pairs? Well, please remember that the base angle pairs are attached to the parallel sides. And since we have parallel sides here with segment OR and segment ZV that are cut by a transversal, that means that same side interior angles are supplementary. So angle ROZ and angle OZV have to total to 180 degrees. So the measure of angle ROZ plus the measure, and we'll just call it angle Z because there is only one angle there at Z in our figure, has to equal 180 degrees. Well, we just found out that the measure of angle Z is 71 degrees, so that means that the measure of angle ROZ has to be 109 degrees. And that happens to be one of our base angles up here. And of course, since it is an isosceles trapezoid, our other base angle has to have the same measure. That means that the measure of angle ORV is also 109 degrees.